Well, good evening, everyone. My name is Anthony Luscre. This is week 2 of the Beginner's Guide to HF, and we also have,
Dennis Kidder, W6DQ, out here in California.
by the way, I'm located in Ohio. Here's my contact information, KZT at awrl.net. And again, remember, we'll have this document available for you in the shared materials after the session and my website. And here's Dennis's contact information and him and his station and his lovely wife.
Aw. Who happens to be sitting right next to me here.
I heard her.
Yeah.
Tonight's presentation will be available at tiny.cc/bghf. That'll actually give you all 3 weeks worth of slideshow. And you can scan this QR code. I'll also have that available at the end. No matter how you get the presentation, whether it's through this link or from the RATPAC website, you're going to want to get to it because you'll see sometimes this little symbol that means that there's a link in there, and there's a number of resources spread throughout the presentation that you'll have to use the links to get to them. So we're going to be breaking this down into 2 main sections tonight on acquiring equipment and antennas and feed lines. And if you missed session 1, week 1, you can watch it on YouTube. And Dennis and I will be alternating here. So let's go ahead and get it started. There's lots of decisions in choosing radios. These are some of the current radios out there. These are some radios from just the last few years, and maybe going back a couple decades for some of these. And then Dennis insisted that we have some classic radios in here. And this is actually my first HF radio, the Ten-Tec Argonaut 515. And a number of these radios are actually in Dennis's shack. So tonight, there we go. Tonight, we're going to talk about HF, high frequency radios. And then there's also another version of radio that's HF that also has VHF and UHF in it, some combo radios. So either way, there's also single band radios, portable radios, base radios. We'll be talking about all those different radios. I know this chart is a little bit overwhelming possibly, but what I want to talk about is what features are typically in an HF radio. If you go out and just buy a generic HF radio, what are you going to typically have in it? So power output, most of the radios you're going to find are basically 100 watts. That's pretty typical. There are some that are QRP radios, 5 to 20 watts, low power. There's also some 200 watt radios out there, but for the most part, if you just go to your local radio store and buy a typical HF radio, you're going to get 100 watts. As far as bands go, most current HF radios go from 160 meters all the way through 6 meters. So you do get one VHF band, 6 meters as a bonus. Years ago, many of the radios started at 80 meters and went up to 10 meters. But most of the modern radios you're going to be buying now typically cover 160 through 6 meters. The alternatives are single band radios or some quad band radios that cover 4 bands. There's also, as I mentioned earlier, some HF radios that also have VHF and UHF. As far as form factors go, typically you're going to be looking at a base unit, but there's also mobile units and portable units. And the distinction between mobile and portable in my mind is the portable radios usually have their own self-contained battery in them, or a way to put a battery in them. That doesn't mean that you can't put the mobile radio carrier portable. That means you can't put that you. It doesn't mean that you can't put it as a base station. It's just a little bit different form factor of the radio. Typically, these radios, unlike the handhelds that you probably have for VHF and UHF, do not have batteries built in typically. Although there are some, as I mentioned earlier, the portable radios that have built-in battery packs or that have a battery pack. The difference being the built-in battery, you can't change it in the field easily. The battery pack, you can have a second one you can pop into when your first battery runs out. Sound cards. Typically, most radios built in the last 5 to 10 years typically have built-in sound cards, and we'll talk more about this when we talk about digital modes. There are many alternatives. If the radio doesn't have a built-in sound card, you can have an external sound card interface such as Signal Link or DigiRig. those all do the same thing as having a built-in sound card. As far as tuning and control, most radios traditionally have a faceplate with knobs. You spin the tuning wheel, you tweak the knobs, you push some buttons, but there are alternatives. There are some radios that are computer controlled, i.e. the Flex SDRs are computer controlled. I know you can buy a Flex with a front panel on it, but typically and initially, Flex radios did not have a control panel on the front. There's also some radios that have external control panels that basically you can have the radio mounted under the seat in the car and then have the control panel mounted on the dash. So a lot of mobile radios have external control panels that can be removed and connected with a cable. Some of the external control panels can also be controlled over a network, so you can do it that way. Some of them also have Bluetooth capability. Mm-hmm. The mixing scheme of the radio, in other words, how does the radio take those HF frequencies and convert them down into audio frequencies that you can hear, and alternatively take your voice or your CW and convert it into RF. Traditionally, the typical radios use super heterodyne type of mixing scheme, but there's other alternatives out there: SDR, direct SDR, hybrid SDR, and then there's direct conversion. So for example, the Elecraft K3 is a direct conversion example. The ICOM 7300 is an SDR. The new ICOM FTDX10 is a hybrid SDR with a super heterodyne type of circuit in front of it. So I actually have some links here that'll take you out to more information on each of these subjects. And if that's the kind of thing you're into technically, you can read about which is best super heterodynes, SDR hybrids. There's another article here in electronic design on SDR transforming amateur radio. And then another link, of course, that goes into yet more. Oops, let's try that one more time. Another link that goes out to more resources. This one, it talks about the ultimate SDR guide. So a lot of information in these links if you're interested in this mixing scheme type of alternatives. Performance-wise, typically a modern HF radio is going to have very good performance, even with a moderate to inexpensive price. You can spend more dollars and get a high performance radio. So I'm talking about radios for the most part in the let's say $900 to $1,200 brand new, have very good performance, but you can go out and spend $9,000 on a radio if you want to, or you could find an economy model for under $700 or even under $300. I just picked up a radio here for $295. It's the Xiegu G106, very inexpensive radio. Definitely not as high performance as some of the other radios, but there are all economical choices out there. And then of course the other choice when you're talking price is buying used. Vintage, we're going to say there is no typical. You might buy a current radio, you might buy what I call a fairly current radio, something that's been built since 2000. Or you can start going back through different ages. You can go back to the 1980s through 1990s, or you can go back to the 1970s when a lot of the radios still had tube finals but transistors in them. Or you can go all the way back and go eliminate all those tubes and go purely hollow state pre-1970 tube only radios. I got into things with a solid state radio, again that Ten-Tec Argonaut 515, so I was never really part of this tube era. Newer used radios, typically most new hams buy a new radio. It's just they know how to find it and buy it that way. But there are a lot of alternatives out there. Buying a current model that's used, someone has already used it, but it's still currently available, or buying a vintage model that's no longer available as new. And sometimes if you want a very specific radio, you might need to go out and buy a used vintage model. Mm-hmm. So the decisions of choosing an amateur radio are many. Not all HF radios are equal. Some are better for CW than others. Filtering is a key here. Some work great for single sideband, but if you want to operate digital, you might need to add an external sound card interface if there's not one built in. Some have built-in antenna tuners, but some of the built-in antenna tuners have very limited tuning ranges. Others can tune very wide ranges. An antenna tuner may not be needed at all if you're using resonant antennas or feeding an amplifier. That antenna tuner may be redundant. Not all HF radios are equal. Some have built-in sound cards, mostly the newer models, making digital sound card modes such as FT8 and FT4 very easy. But you can use an external sound card interface for approximately $100, even less if you go out and shop for some of the newer or a used version. If you do not operate these modes, though, it may not be useful. But it cannot. Don't limit your idea on a sound card to FT8 and FT4. Digital sound card interfaces can also be used to send single sideband messages from contacting software via macros to the radio. You can also record on-air audio to a computer using the built-in sound card. And if you want to work traditional digital modes like RTTY, the built-in sound card can let you do those too. So digital sound cards are not just for FT8 and FT4. Used radios are great buys, and other used radios are projects at best. So again, there's a whole range of used radios out there, and you might get something great or you might get something that's not so great. One of the things to remember is not all radios are the same. Some cheap radios may actually cost more after adding missing features that you want or need. Sometimes the solution is actually 2 or more radios, a starter inexpensive used radio until you get an idea of what you want or need for HF, or an inexpensive compact QRP radio for use while hiking, for parks on the air, or maybe a 100-watt mobile for your vehicle if you have a vehicle you want to operate from. And then having a traditional 100-watt base station for shack use. So sometimes having more than one radio makes the decision easier, and you can focus on what you need at each specific location. There is a way to get started listening to HF without buying a radio at all and without having an antenna. I wish I had this when I was a kid. This is my grandson, Holden. He's operating a software-defined tunable receiver via his phone. And there's hundreds of these around the world that are free for your use. They don't let you transmit, but they do let you receive. So it's a great way to listen to HF amateur radio without having an amateur radio HF amateur radio at your disposal. It allows you to tune online receivers, and then you can even transmit your own signal from your traditional radio and listen to yourself if you want to. So I have 2 presentations on software-defined radios. The first one is a short 4-page quick guide that I use with students called it's called Free Shortwave and Amateur Radio Receivers, online SDRs you can tune and listen to, and it talks about how to find them. It talks about how to use them. It gives some information on some other sources. It also gives a little bit of information on shortwave listening, gives some information on how to find stations using DX clusters and other spotting methods. And then it has a guide for which bands that you can listen to amateurs on with which modes, how to set the filters on the SDR, how to choose between day and nighttime operation for which bands you want to listen to. And I've been using this for a number of years with 5th through 8th grade students. So feel free to use this. It's tiny.cc free RX. I'll actually put this in the chat here. Actually, I'll grab it from here. It's easier. I also have a full presentation on online software-defined radios, and there's also a recording of it available from a previous session I did somewhere. I have another slideshow on, it's called tiny.cc buy AR, and that is a whole guide on buying equipment, choosing the different features you need, ways you can buy radios, used, different venues you can find used radios in, Hamfest, demo units, how you can buy new equipment. And then I also have an accompanying spreadsheet, which I'll pop open here, that compares different radio features so you can get an idea. This first, there's a number of tabs on this. The first tab is the HF rig matrix, and these are radios that are either new, currently available, or just been discontinued very recently. And you can go through this list and you can look at the radio models. Most of them have links for more information, and it'll tell you, for example, what type of form factor it has. In other words, the style. Is it portable, base, mobile? Does it have an internal battery? Does it cover HF 160, or does it have single band? Does it have 6 meters? Does it have 2 meters and 70 centimeters? Digital VHF, internal antenna tuner, computer controls, built-in sound card, CWD code, a list price, discounted prices because sometimes there's offers from different manufacturers for rebates and discounts, and an idea of what some of the used prices these are going for typically. Some notes on for each of them, and then just the models here again. So you can go through this whole chart, but when you scroll down to the bottom of it, you'll see that there's a whole variety. But you click on the next tab, HF, and it gives you a list of transceivers for the last 20 years. This is provided by Universal Radio, the links that are built into here. So you can go to this and find out information on a radio that's been discontinued for many years. I also have another very similar link matrix for mobile VHF, UHF radios that we talked about in the VHF presentation. Remember, there's a 3-week presentation available on that in our recordings.
All right.
So now we're going to turn over to Dennis.
Uh-oh. Well, that's some great information. And boy, I'll tell you, Anthony, I use the web SDRs all the time. They're fantastic. And you've done another presentation where you talk about checking your signal, improving your station. Web SDRs are indispensable for doing that. You can actually monitor and record your own station at a distance anywhere in the world, which is kind of cool. All right, well, we're going to talk about the components that make up an HF station. And this is the basics. This is the starter goodies that you need. And typically you're going to start with a transceiver, but a lot of these transceivers they don't have built-in power supplies. They don't run on 110 line voltage. They run on 12 volts DC. Some of them even run on 24 or 48 volt. They have external power supplies to run them. So you've got to possibly have a power supply to run your radio. You need something to hook that radio up to. So you're going to need an antenna. And the antenna can be, we're going to talk about that later, but there's such a wide variety of antennas that you can use. We have quite a collection of antennas here, everything from simple vertical, quarter wave verticals to half-wave dipoles to the latest edition, which is a horizontal loop for 160 meters. It's a full wavelength in length, 544 feet of wire up in the air. We've got Yagis, directional antennas, all these different kinds of antennas. And there's any number of possibilities that'll fit your budget. If you have a minimal budget, wire antennas are great. An infed, for instance, infed wire antennas, simple as they come and very, very economical. But you also have to be able to get from the radio to that antenna. So we want to talk about feed line, and typically that'll be coaxial cable. In some instances, you'll use other things like what we call open wire balanced feeder or balanced lines. So that's a little different type of feed line. You may also have to come up with a microphone or a key. Most modern radios that we've been talking about, like ICOMs, the ASUS Kenwoods, they typically come with a microphone. So you don't have to worry about that. But you might, if you want to learn CW or you're going to be active on CW, you'll need a key or a keyer to do that. Of course, you can also use a computer to do CW as well. So anyway, so here's your typical station. You've got a, I don't know, what have we got there? We got a Yaesu FT991. With the mic that came with it. We've got a fused power cable, most important. We don't want to have any accidents. And a 12 volt power supply. Yes, we can share stories about low 12 volt power supply accidents on radios. They do take their toll sometimes, but that's the basics right there. The coax coming in from the antenna. So some other things you might need. An antenna tuner. If you've got a non-resonant antenna or an antenna that's not presenting a 50 ohm load to the transmitter, the transceiver, you'll need to have an antenna tuner or a coupler. If you want to tie into a computer to do the digital modes, you might have to have a sound card interface. Like Anthony said, many of the modern radios, and one of my favorites is that ICOM 7300. You just plug it into a USB port and you're ready to go. It's amazing. So it does all the audio and control lines through the USB. So sound card interface, if you're using a radio that doesn't have that built in, that's an important piece if you're going to do digital modes. A keyer for CW, instead of using a straight key, you might want to use a keyer. And keyer gives you a little bit more speed and a little bit more control of the shape and style of your characters. Voice keyers are cool, and Anthony kind of touched on that. Voice keyers are great for contesting, and what it is it's a way to record a message that you're going to repeat a lot. Like if you're in a contest, you're saying CQ contest, CQ contest, CQ contest for 48 hours straight, you're going to get hoarse. So you get a voice keyer to do that for you, and so you just push a button. And of course, you can do the same thing with Morse code and have an automatic keyer as well, where you can have canned messages, which is fun. CAT, this is a computer-aided transceiver is what that stands for, and it's basically an interface to the radio. Traditionally, in the old days, it was over an RS-232 interface. It's like I said, this has evolved into USB, doing a serial line over USB. And so you might have a computer interface to the radio, as well as some software that allows you to control the radio, which is kind of cool. ICOM's got what are they? I got the software. I can't think of what it's called, but they've got a package where you can actually remotely control the 7300 with their software, which is really neat. If you're using a directional antenna, you're going to want to have something to be able to turn that antenna. You can have an Armstrong rotator, which means you just move it by hand, but it's a lot easier to have an antenna rotator that does that for you with a control box, so you know where it's pointed at any time. This idea of a coax cable AV switch, maybe you'll have multiple antennas for different bands, so you want to be able to switch between them. Some radios have that built in, where they'll have two outputs, an antenna A and an antenna B, but a lot of radios don't have that, and you need a way to be able to switch between antennas. So that's one option. You can also use it to switch between radios if you want to hook different radios up to a particular antenna. And if you've got a lot of accessories that are powered by 12 volts DC, you probably want to have some kind of a distribution system. And so we'll talk a little bit more about that a little later.
Yeah, next week we'll talk about actually setting up your station, and we'll cover that aspect of wiring things together.
Absolutely. Power supplies. So fundamentally, we've got two different types of power supplies that we use. The traditional power supply is a linear power supply. It uses a transformer and a rectifier and a filter and maybe a voltage regulator to give you a constant output. And the beauty of a linear amplifier is that they're very quiet. They don't generate a lot of noise. The downside is they can be very heavy because they've got a lot of iron in that transformer. So the solution to that weight problem is to go to a switching power supply. So switching power supplies, they basically interrupt the AC line voltage at a high frequency, maybe a few hundred kilohertz, and then that's rectified and filtered and regulated down to the voltage that you want. And it's a very simple process. The problem is some power supplies are quieter than others. And that's going to be something that you need to be aware of. Some switching power supplies, in particular, our lowly little wall warts are typically switching power supplies, and they tend to generate a lot of RF on HF. So you have to be wary of that. So, and Anthony's got a link here to another page that talks about the differences between linear and switching power supplies and what are the advantages and disadvantages of each. So there's some good information there on that. Output of these power supplies, we typically call it 12 volts, but nominally it's 13.8. 13.8 volts happens to be the output of your regulator in your automobile, and that's where that comes from, 13.8 volts. So we try to run everything at build radios that will run at 13.8, maybe a little bit higher, so we don't damage them. But we typically refer to that as 12 volts DC. So, and current is a big deal. Depending on the output power of the radio, it's going to determine the size of the power supply that you're going to need. So like we say here, a 100-watt HF rig that runs on 12 volts might require 18 to 25 amps or more during transmit. So getting something that can handle more than 25 amps if you've got a bunch of accessories is a good idea, or if you're running multiple radios. We've got a couple of power supplies here that I can run 3 or 4 radios on. They're like 60 amp power supplies. So yeah, they're 12 volts at 60 amps to be able to run several radios at the same time it's a little over the top. But higher current, higher amperage in the power supply is a good idea if you're going to run a lot of stuff. And that refers to accessories as well. Okay, power wiring. One of the neat things that's come out in the last couple of decades are these Anderson power poles that are illustrated here. And a lot of the emergency comm groups have standardized on Anderson power poles and the way that they're um, connected. In other words, the polarity of them. These things are modular, so you can kind of switch them around any way you want to. But what's neat is that if everybody follows that sort of de facto standard, everything's interchangeable. And that makes it a really beautiful thing that you can operate with other people's equipment and still have the same power source. And they're flexible enough, so if you have the thing backwards, you just take it apart and slide it back together in the correct orientation. So these are really great things. These Anderson power poles are very inexpensive. Typically we crimp them, but they can be soldered as well. A lot of power supplies now come with them built in. A lot of radios come with them built in. So you have Anderson power poles in the radio to hook your power up to it, which is cool.
And
Most
Dennis, I just realized I have a backward illustration
yep.
here. This is
Look,
actually the
look.
backward standard, so I'll
Yeah.
correct that in the slides.
Yeah, I'm looking at that and going, uh-oh.
Yes.
Yeah, that's right. Yeah.
So you want the trick is when it's facing away from you, you want red on the right.
Yeah. So that's cool. I'm glad you caught that. Yeah. Don't follow that illustration right now.
We'll fix it.
You've got some videos on there about installing them and what have you. They're, like I say, they're very easy to put together and install. And we use them everywhere here on all our 12-volt stuff. Power distribution and wiring. If you're running multiple accessories, in the old days, you just had a couple of binding posts. You connected everything to the binding posts on the power supply. That could be a pain. Well, the newer systems, and of course you've got the MFJ. The ones that I really like are the ones from West Mountain Radio. Is that is the one up there in the top? I'm not sure. Is that the HRB ham radio workbench one?
I think that is.
Yeah, it kind of looks like the one that he did. That's got a digital voltmeter on it. It may even be an ammeter to let you know what your current drain is. But the MFJ, these things are great. You see that each output is fused as well as the input. The input is fused on these, and you have outlets that are on the MFJ that are always on and outlets that are switched as well. So these are really handy if you're going to connect a lot of stuff up. So you want to be aware of those and be aware that you can use those to make your life much simpler. So let's see. Where am I? I'm lost. There we go. What else will I need? I mentioned a microphone. If the radio doesn't come with a microphone, and like we say, most new radios do, but if you're buying a used radio, the microphone may be missing. You're going to want to get a microphone for it. Be aware that different radios take different kind of microphone interfaces, and there's multiple types of microphones. We've got high impedance microphones. We got low impedance microphones. You got to make sure you get a microphone that's intended for the radio that you're going to use. It needs to have the correct pin out, and some radios use these little 8-pin. It's a circular connector that's a multi-pin connector that goes in with a screw captive on it, ring on it to hold the thing in. Others use your typical Ethernet type RJ45 connectors. So you got to be aware of what your radio uses. Again, CAD interface cables. We talked about this earlier, what these are. USB cables are more common now. So you can use that to connect for CAD or for your sound with radios like the IC 7300 we mentioned. I think the 705 uses that as well. It uses a USB interface as well as a Bluetooth interface, which is kind of cool. A lot of the older radios have an RS-232 interface on it, like a DB, might be a DB25 or probably a DB9 connector, one of the sub-miniature DB connectors, the sub-miniature connectors. What you'll need to do is probably, if your computer doesn't have a serial interface RS-232, you'll have to get a USB cable that has the converter built into it that converts the RS-232 to USB. So yeah, and this is a very important thing. This FTDI chip is pretty critical. Some of these things work, some of them don't. Yeah, don't cheap out on the USB to RS-232 adapters. There are good ones out there, and you're going to pay a little bit more money for them, but they're not going to break the bank. They're not super expensive. So that's a good thing to be aware of. Headphones. Some of us find it easy to operate with headphones. Um, and again, like the radios, there's a wide price range. You can go anywhere from inexpensive to spending hundreds of dollars, like the ones, well, you can't see it, but I've got a couple of sets of headphones here that are from Radio Sport that are like $250, $300 each, but they are wonderful. You can wear them for hours and hours and not have any fatigue from them. And they've got a built-in microphone, and they're just very nice headphones. So you want to think about that. If you're going to use headphones a lot, you want something that's comfortable. But, inexpensive little Chinese headphones you get on eBay, or not eBay, on Amazon may do the trick. Spend $20 or $30 and get something nice.
I just wanted to mention one thing about
Yeah,
headphones real quick. Some
yeah, yeah.
people, like myself, I find that I like very different headphones for when I'm doing CW than when I'm
Mm,
doing phone.
mhm.
So I tend to have most of my headphones that have my microphones on are the ones that I use for single sideband, but I find that I like a very light and a very different headset for CW.
Mhm. Yeah, the radio sports that I use, they are not lightweight. They look kind of like the David Clarks that you have if you're a pilot and you see pilots wearing their headsets. They're heavy, but they are heavy duty, and they really sound good, and they're very comfortable. And a bunch of different models that they have available. Um, what's really cool about that I like about and I'm not plugging, I guess I am plugging Radio Sport, but one of the neat things about it is one set of headphones has a jack on it where you can plug another set of headphones into that jack. So if you've got two operators, like let's say on field day, where you've got one guy operating and one guy logging, you can both wear headphones and hear the same thing. So that's kind of a neat idea. I like that. On the other hand, we're talking about voice or hands-free operation. Vox or voice operated transmission is a very common thing. Vox is pretty much a standard feature on any radio today, and uh, you have to be careful with it because any noise will set it off, and including when you get upset at your radio. I don't use Vox for that very reason. Foot switches, a foot switch where you can push a foot switch to do push to talk is great. I use them sometimes. One of the problems I found is I get to chase the foot switch around on the floor because they don't stay put. So it's always fun.
And I found success with some atypical foot switches. I have one here that I really like. It's designed for actually a sewing machine,
Oh
and
yeah.
it's got three buttons on it, so I can press the center or press the left or right. I can actually do different activities with it. It doesn't slide away. And one of the things I dislike about some of the name brand amateur radio foot switches is they require too much pressure. I
Yes.
want something that just requires a minimum pressure. And I actually found something for field use that was very inexpensive. I found a tattoo machine switch on eBay
Oh
that's a
yeah.
very thin piece, two pieces of metal that just go together, and I can use it as a hand switch or as a foot switch in the field. I don't have to worry about messing it up. It can sit in dirt and not get ruined.
Not get ruined. Well, my thought these days, and I'm planning on doing this soon, is a knee operated switch under the table. So I just lean up against it and it keys the transmitter, or some type of a switch there. So I don't have to use my hands. I don't have to use my feet. I can use my knees. Okay, so with regards to microphones, obviously no two microphones are the same from different manufacturers. Every microphone has its own characteristics. Every person has their own voice characteristics. And so you want to pick a microphone that suits your voice range and matches your transceiver or your transmitter so that you get the sound you want. And we mentioned this earlier, using the online SDRs are great for doing this, although I will caution that using the online SDR, there is a delay, right? So when you speak, you're going to be waiting a bit for it. So it's going to be like an echo, and it can be a little bit disconcerting when you're listening to it. So a better way to do it is to use the SDR and record it and then play it back later. So you're not trying to talk at the same time you're listening. But you're going to look at things like your mic gain. That's going to be important. If you get the mic gain too high, you're going to have distortion. Compression is another one. We like to have compression because that increases our output, our average output power. It doesn't change the peak power, but it changes the average output power. And so we get a little bit heftier signal with compression. You'll notice that guys working contests and guys working DX will have very heavy compression. So they're getting a lot of output, average power. But it can also lead, again, to distortion, overloading your transmitter, all kinds of things. Some radios also have additional settings. The flex that I have here, all of the flexes that I have here, there's a cadre of them. They all have built-in equalizers, so I can actually tailor a graphical equalizer to my voice and the microphone that I'm using on that radio, as well as on receive. It has the equalizer on receive as well. It's like an octave equalizer. It's like I want to say it's like a 9-band equalizer. So it's not super critical, but it's great for tailoring it. And again, having someone else listen to you or listening on the web SDR is a great way to set that up. So again, Anthony's got more links here in his All Bands blog, the reducing splatter, very important. A lot of people, especially if you're looking at it with a flex, and I use the flex all the time, and so I see what signals look like. And splatter occurs when you're overdriving your transmitter, maybe overdriving an amplifier, having the mic gain too high. Splatter is really annoying because it affects all the guys to the right and left of your up and down the band, right and left of you on the display there. So you want to be real, as a considered operator, you want to reduce the splatter. Again, I mentioned this clean, punchy, competitive contest audio without splatter. It's easy to do. You just have to set the audio settings on your radio correctly, get some help, but also listen to it and monitor what you sound like. Monitor your own signal. It's really important. All right. Yeah, that's a great presentation.
And really, what the last point of this one is the way you talk into the microphone affects it also. Mm-hmm. So remember, as you set up that microphone, make sure it's set up the way you're going to be talking into it on a regular basis.
Yeah, different microphones have different patterns. The pattern of their sensitivity. So different microphones, you're going to handle them differently. We've been trying to get Steve on here. We want to get him on here.
Yeah, if anyone knows Steve, tell him we're waiting for him to get on here.
Yeah, we've been trying to get in touch with him, but haven't had much luck. All right, so antennas. We talked a little bit about this. Is kind of a major thing you need to get your radio on the air. You need some kind of an antenna, and the simplest antenna that's out there is a dipole. It's just 2 pieces of wire with a feed line, and there's a good illustration of it. And I'll tell you right now, with 10 meters being open, this is a very, very small antenna for 10 meters. And 10 meters, you can work the world with this. With 10 watts, a 10-meter dipole, and a good band opening with the solar cycle where it is now, you can talk to people all over the world on HF, which is wonderful. So this is a table that gives you the approximate lengths of the dipole antenna. One of the things, you have to have a supports for a dipole. It needs to be supported at both ends. Sometimes they need to be supported in the center as well. Well, if you don't have the room for that, or you don't have the supports, consider putting up an inverted V where you just need one support in the center. And the beauty of an inverted V is they're very close to 50 ohm feed point impedance, which is nice, but they're also more omnidirectional. A dipole, if it's at the proper height, is somewhat mildly directional. You'll have nulls off the ends of the antenna. An inverted V corrects that, and it's more omnidirectional. So that's kind of a nice thing to be aware of. I do use inverted Vs here. We have 4 bands because they take up a lot of space, and they only require one support. So one tower, I can hold up a couple of inverted Vs for different bands, which is really great. All right, I started talking about this a little while ago, different types of antennas. And again, this is something we could go on. We could do multiple weeks just talking about antennas. But these go from, the wire antennas. Wire antennas are the simplest thing you can do. So dipoles, inverted Vs, which we mentioned, an in-fed half-wave dipole. So an in-fed can be a random length as well with a tuner, but an in-fed half-wave, see, a dipole is a half-wave antenna, right? So you can feed it at one end and it's still a half-wave antenna and it behaves like a dipole. But again, you have to have those supports. You can also do something like OCFD, off center fed dipole. And these are great because they become really nice multi-band antennas. A sloper is another one that's simple. If you have a single support, a sloper antenna requires, it's kind of a variation on a vertical with a sloping element, but you really need a good ground plane. You need radials and all that for a sloper to really, really work well. Just like an inverted L. An inverted L is just what it sounds like. You've got a vertical section and a horizontal section. So it's an upside down L. Again, it's a vertical antenna, so it needs a good ground plane. So you need radials for that. So it takes some real estate to put those things up. But inverted Ls, like for the lower bands for 160, 80, and 40, are a great antenna. They're a great compromise because it reduces the height of the antenna. It makes an electrically the correct length, but it's shorter physically because that inverted, that horizontal section actually loads the antenna capacity as a capacity hat, which increases the electrical length of the antenna to make it more attractive to your transmitter. So it's going to be resonant, provide a closer impedance match to 50 ohms. We can make antennas out of feed lines. You've probably run across J-poles for 2 meters or 440. J-pole is a real simple antenna. You can make a J-pole out of twin lead, basically. Very, very simple antenna to make, and multi-band, very portable, which is nice. You just hang it in a tree if you're portable. So J-poles are great. Bazooka antennas are really, really kind of a cool antenna. These things are actually pretty quiet. It looks like a dipole, but it's made with coax. So the part of the element is a piece of coax. And then they have a wire extension on the ends. And there's a bazooka and a double bazooka. These are all great antennas. They're very, very efficient. They're broadband and simple to make. So inexpensive, just some RG8X coax and a center insulator and some wire, and you can put together a bazooka. Flower pot antennas. I think of a flower pot antenna as like a stealth vertical, but I'm not sure what you're talking about there with a flower pot antenna. I think
they're very similar to a bazooka,
yeah,
but they use a coil in them that you make out of the coax.
Okay.
Very
All right.
similar to bazookas.
Okay.
It's
Yeah.
sort of a vertical bazooka.
Okay. Yeah, I've run bazookas and I do like them. They're a little bit more complicated than a dipole, but they are quieter than a dipole and they're more broadband. So that's neat. Aluminum. We use aluminum for antennas. That's a good antenna material because it's lightweight. So we talk about vertical antennas. I mentioned that earlier. A quarter wave vertical. A quarter wave vertical for 10 meters is quite compact. But again, you need a ground plane. You need those radials to make that work. But verticals are great. You can even put up multiple verticals and have them in an array to have a directive antenna. So that's kind of a slick thing. A little bit more complicated, but if you want directivity at the lower frequencies, where it's just like 75 or 80 meters, you're not going to put up a Yagi. They're made, but you're probably not going to have a Yagi up on 80 meters. Using phased verticals, you can get considerably greater performance than you can with just a single vertical or a dipole. So that's kind of a neat thing. And we talk about beams. I mentioned Yagis. A beam antenna is a multi-element antenna that expresses gain in one direction. It expresses nulls to the side, and it may have a null to the rear. We talk about front to back ratio on an antenna, a Yagi or a beam antenna. So you have all your energy is being directed in one direction, and you're receiving energy from that direction, and you're attenuating the energy that's coming from other directions. So if you've got strong interfering signals off to the side of a Yagi, they're going to be attenuated and you're not going to hear them as much. So that's a nice thing about Yagi antennas. Typically, the typical Yagi antenna might be a tribander, which will cover 20, 15, and 10 meters. That's the traditional tribander antenna, and they're fairly compact, fairly inexpensive. There's a number of suppliers out there of those, and a good starter antenna to cover 20, 15, and 10. You can also get them to cover the WARC bands as well. So I highly recommend, if you've got the space and you've got the budget for it, beams are great. They're a great antenna to have up. Hybrid antennas, and this is an interesting thing. The cobweb or the hex beams. These are a combination of, is that mine's going off? phone's alarms going off at me. The cobweb or the hex beams, these are types of Yagis that have wire elements, and the elements are actually folded back. So they're compact. And referred to as a cobweb is, if you look at it, it looks like a spider web. So these can be multi-band antennas that cover, again, 20 meters, even 40 meters. There's 40-meter cobweb antennas, 40-meter hex beams. Some really nice, lightweight, portable, and, well, I'll say portable. If you've got the time to set one up, they're portable, like for field day, because they're super lightweight. It's just wire and a bunch of fiberglass poles. So you can imagine it's going to be a fairly lightweight antenna. Loops are another excellent choice. A horizontal loop by far. I mentioned, I just put up a horizontal loop here for 160 meters. It's 544 feet of wire, 50 feet in the air. So I've got 4 supports. It's square. It's fed with a balanced feed. So ladder line feeds it. And I have to have a tuner, which is actually sitting, if I can point to it, those are the tuners for the loop right there. I've got 2 different tuners for different bands. So very, very interesting antenna. They're a lot of wires, so they've got a lot of capture area. You get good signal strength, good receive signal strength, because you've got so much wire up in the air. Horizontal loops are great. And that particular one covers 160 meters through 10 meters, all bands, just with a tuner, piece of cake. Vertical antennas, I mentioned that before. Vertical loop. So a vertical loop is, well, you see, you're talking about mag loops. A vertical loop would be like a delta loop, which is another wire antenna. Delta loop is, if you've got the space and the supports for the lower bands, delta loops are very efficient antennas for the higher bands, for 10, 15, 20 meters. They're fairly compact, and you can get by with two supports, and they basically, you have a horizontal wire with 2 wires coming down to a feed point at the center, and that's your delta loop. I've seen delta loops for 80 meters and 75 meters as well. They're pretty big, but they do work well. And the cool thing about delta loops, those vertical loops, is you can stack them like you would a Yagi, elements in a Yagi. And so you can have a driven element and directors and a reflector, so you can have energy going in one direction. Let's say, like, you want to work Europe on 40 meters, you can build one pointed at Europe and be able to have some gain in that direction. So that's delta loops are slick antennas. Compact transmitting loop or a magnetic loop. A lot of commercial products out there for this. It's basically what we call a shielded magnetic loop. It has a piece of metallic tubing that has a gap at one side. And it's essentially multi-turn loop antenna inside that tubing, and then it'll have a coupling network to connect into that wire that's inside the loop. A little bit more complicated, not as efficient. I'm sorry, I'm losing my voice. I need to take a drink here. Not as efficient.
Well, fortunately for you, Dennis, this is the slide where I take over.
Okay,
So
well, I was going to say
Dennis
they're actually very compact, which is
Yeah.
one advantage. You can actually put them in a very small space. So,
The
okay,
one disadvantage of I was just going to add the one disadvantage to them is whenever you change your frequency, they require retuning. But the nice thing is, if you're using them on FT8 or FT4 where you're not changing frequencies, they work very well for that.
Yeah.
So I'll continue now on HF antennas. And one of the things about HF antennas, they're subject where there are multiple presentations, and we have multiple presentations on RATPAC. You can look up information on them. We can only scratch the surface. The size and complexity of putting together, supporting, erecting, and feeding an antenna in any zoning HOA restrictions can dwarf the other aspects of getting on HF. Don't let this stop you. A lot of people get stopped in their tracks when they talking about HF, when they start talking about putting up antennas, because it's very simple with VHF and UHF, but it gets a lot more complicated because of the size. Basically on HF antennas is much bigger. Some of the problems with antennas. Unfortunately, antennas can be the downfall for hams just starting out on HF. First of all, you run into a lot of exaggerations and misinformation out there, both in person, online, written material, commercial hype, etc. There's way too much anecdotal evidence based only on casual observations, i.e., I worked the Czech Republic on this antenna, so it must be great. It really doesn't mean anything. We're not comparing it with anything. There's nothing to this. So you'll see statements like this all the time in advertisements, and it's a bunch of hyperbola. It doesn't really help out the UHAM especially. Many of the issues with antennas result from trying to avoid a couple things. The first thing is we try to avoid large size, so we'll make the antenna smaller than it really should be. And that can sometimes work, but that becomes a compromise. The next thing we run into is support erection issues. For a dipole to operate properly, it needs to be a specific height above the earth. And when you start talking about antennas with 80 meters or 160s, that's really much, much higher than you would expect. It's not 20 foot. It's not the length of a fiberglass pole that extends. So that can be a problem. And then also the whole idea of keeping an antenna up in the air. With Dennis's 500-foot antenna, there's a lot of weight up there involved. So I'm sure his poles are not just little bamboo sticks sticking up out of the ground.
A lot of wind load too.
Yeah, a lot of wind load, a lot of Dennis doesn't get any ice load there, I don't think, but we do get ice load here.
We get
he gets heat load.
No, we get wind.
To get hot enough to let everything sag there, Dennis?
Yeah, everything sags. I wouldn't be surprised. I have to keep an eye on that, but we get a lot of high winds out here, in excess of 70, 80 miles an hour, and they wreak havoc with antennas. So we have to build things strong.
Another thing that we often try and avoid is it's the idea of let's put a vertical in the ground. It doesn't take up much space, but really for a vertical to work properly, most verticals, unless they're designed specifically to avoid it, require radials, and the more radials, the better. So this counterpoise of radials is very important. We also try and avoid visibility, so we try and create stealth antennas that we can't see. And then there's also effort required, assembling, constructing, proper installation, etc. All of these things, as we try to avoid these, usually compromise our capability. So it would be great. I just worked blank with 1 watt with this, and if this is the only thing I needed, that would be great. It would be very simple. And you know what? I have made contacts on devices like this, but if you want to make contacts consistently with places anywhere around the world, you're going to need a little bit more than this. But you can make contacts with this.
You can.
I have a whole presentation on antennas. This originally started out as a cheat sheet for people that were doing field day for the first time during the pandemic. I put this together for local club members. So it actually started out as a portable antenna list, and that's why the shortcut for this list is called Port Ant. I'll put that in the chat. But I basically talk about pros and cons of different types of wire antennas, verticals, beams, magnetic loops, integrated mobile antennas. Then I go through and provide information with links to both do-it-yourself and commercial antennas for each of these different varieties. So information on half-wave resident dipoles, non-resident dipoles, non-resident and resident fed end feds. And you notice wherever there's a commercial product, I try and list it as commercial. Inverted V and sloper antennas. I'm running an Alpha Delta DXA twin sloper for 160 and 80 meters here. It does a good job with my 5 watts, but it's not the best antenna in the world, but it does a very good job.
Decent antenna. Yeah.
Yes. Verticals, whole information on that. Beams, stealth and indoor antennas, 160 meter limited space antennas, magnetic loops and compact transmit antennas, integrated antennas such as rubber ducks, backpack whips, etc. Pedestrian mobile staff such as the buddy pole. The buddy pole actually has both a commercial product you can buy, plus they have plans for building your own. So if you've ever thought about a buddy pole, you can build your own buddy pole and try it out. Mobile antennas, VHF, UHF antennas, of course, don't cover today. And here's a little chart from the Villages group.
That's cool.
It's an amateur radio group in Florida. I'm actually doing a presentation for them on Thursday night, and they have a guide here because they have a lot of HOA requirements that people have in their areas. So they put together and graded each of the antennas on their stealth, on the air capability, installation, cost, and effectiveness on the various bands. So this chart is available from the Villages group.
That's a great chart.
So that's all information on antennas. Just to give you an idea, here's my antenna setup. I live on a fairly small suburban lot, 75 by 160 feet. And you'll notice I am lucky enough to fit a tower in there. I squeeze the tower into my little lot. I do have a multi-element beam on there. It's the Sumner XP 850. I'm sorry, XP508 covers 6 meters through 30 meters, with 30 meters being a rotatable dipole. I also have that Alpha Delta sloper. Here's the 160 leg. It comes down to the edge of my driveway, and the 80-meter sloper actually goes through this tree to the chain link fence in the back. That really made a big difference. This opened up working Europe on 80 meters, and it's oriented towards Europe. The slopers are a little bit directional. They are omnidirectional also, but there is some direction ability on that. I also have a 43-foot DX Engineering vertical with a remote tuner at the base of it that you can't see because of the trees here. And I use mainly on 40, 60, and sometimes on 30 meters. So that's my antenna setup. I have worked over 105,000 QSOs, not all of them with these antennas, because over the years the antennas have changed, but these antennas have allowed me to work all states on all bands with 5 watts. So I also have, I'm approaching 316 DXCC. So it doesn't, you don't have to have a monster lot or monster antennas. For planning your antennas, one tool that can be very helpful is Google Online Maps. You can actually do measurements. This is where I operated field day from Triadelphia, West Virginia in 2021. Before I went, I had to figure out where I was going to put my antenna up. So I went on Google Maps, searched for the site that I was going to, the Airbnb, and found that I could run this wire. It turned out better running this wire actually from here to this tree and then down to this tree. So I actually made like a giant L-shaped end-fed antenna. I also had my hex beam on the corner of the house here, bungeed to the side of the deck on some little mast poles. Feed line, you know what? Let me fix this. I zoomed in here and it's going to cause havoc in some of these slides. So let's fix that real quick. Okay, that'll help. And let me just fix one other thing real quick here. Okay, so I think we're back to Dennis.
Oh yeah, that's right. It is. All right, feed lines. Okay, we mentioned a few of these before. And you can see here we've got our coaxial up there in the upper right-hand corner, coaxial cable. That's probably the most common thing that any of us would ever use. RG8, RG8 X, or RG8X is that's can't even think.
We have a slide coming up on that, Dennis. Don't worry.
Okay. Yeah, that's right. There is a slide coming up on that. But different types of coax, different characteristics, different cost for coax. Be cautious of what you buy. I will warn you that I bought some RG8X off of Amazon a little while back, and the stuff was garbage. So I just, you never know. I like to, that's why I tend to stick with the known commodities. I've talked about balanced feed lines or twin feed lines, open wire. And this is exactly what I've got feeding my loop, is what you're indicating right there, Anthony. It's made with the black PVC pipe with the notches in it, and it's a 600 ohm balanced feed line, and very inexpensive to make, beautiful, easy to make. Window line, that's what he's showing you here. It basically looks like television twin lead, except it's a little wider and it's got holes cut in it. So why are there holes in it, you might ask? Well, in the case of where Anthony lives, where he gets ice will build up on the feed line, and it'll change the characteristics of the feed line. So window line, it's lighter weight, but it also, if it gets ice loading on it, it's not going to have as many issues with changing its characteristic impedance. And the width that actually spacing of the two wires determines that impedance, along with the gauge of the wire, the side of the wire, size of the wire. We talk about velocity factor. If you're familiar with velocity factor, it's basically all materials, light or radio waves travel at the speed of light in a vacuum, but as they go into different materials, they're going to slow down. And so velocity factor is how we talk about how the speed of the wave through the feed line slows down as it's passing through that feed line. And it's because of the characteristics of the dielectric material, the insulation material, the dielectric, and what have you, is what determines that velocity factor. So different feed lines have different velocity factors. Something you need to be aware of if you're looking to make a specific length that's a relative to a wavelength of coax or ladder line or open wire feeder. It has an effect on that.
Now, a lot of new hams say, why are you messing with any of this stuff at the bottom here when you can just go out and buy coax?
Sure.
Well, there is some big advantages of these. For Dennis's antenna, he has a rather long feed line, and these have a lot less loss than even really good coax when installed properly.
Well, probably the bigger advantage of using an open wire feeder is that it's broadband. You know, a piece of coax hooked up to an antenna, it's going to limit what you can do with that antenna. In other words, it's going to restrict the bandwidth of the antenna because of impedance matches and what have you. Ladder line, using like this, the one down there in the lower left, I can put up a dipole for 160 meters, or let's say I put up a dipole for 80 meters, and I can use it on 80 meters through 6 meters with a tuner. And I couldn't do that feeding a dipole with a piece of coax. It wouldn't work that way. So that's a nice feature of that. Yeah, we were talking about different types of coax, different diameters. RG8, RG213. This is traditionally like a 1/2 inch diameter, a little bit less than 1/2 inch. Power handling capability. That diameter of the coax will really determine the amount of power that it can handle. You don't want to be using something like RG58 and running a kilowatt. It doesn't like that very much, but RG8X will handle a kilowatt without too much trouble. The diameter may relate to the loss of the feed line, and the loss increases as you go up in frequency. So that's an important factor. UV resistant, extremely important, because your coaxial feed line is probably going to be outside. You may have an antenna in your attic if you're in an HOA or something that you can't have an external antenna. So you don't have to worry about that. But most coax that you're going to get these days is UV resistant. It's UV stable is what they refer to it. And direct burial, if you want to conceal your feed lines out to your antennas, direct burial coax is great. It's going to cost a little bit more money, but you don't have to worry about putting it in the ground. Impedance, we've talked a little bit about that. 50 ohms, actually 52 ohms is the traditional specific impedance of most of the coax that we talk about. RG8, RG213, LMR 400, all the common things, RG8X, these are all considered 50 ohm coax, which is also typically the characteristic output impedance of your transmitter. So it's usually 50 ohms. 75 ohms is used for cable TV, commonly. Used for video applications are always 75 ohms. So video applications for your computer, things like your computer monitor might have, if they're discrete or component video, would be 75 ohm coax. So you need to be aware of that. But honestly, using 75 ohm coax to feed a 50 ohm antenna, you probably won't even notice the difference, honestly. What you might use a 75 ohm coax for, and this is very important, I mentioned phased vertical arrays. We have to have a matching section, because we're going to take two 50 ohm antennas, let's say, and put them in parallel. So what are we going to get? We're going to get a 25 ohm load. Well, that's not going to, your transmitter may not like that. So what we want to do is convert that 25 ohm load over to 50 ohms, and we use a matching section to do that. And traditionally, I shouldn't say traditionally, but typically what works great is 75 ohm coax can be used as a matching, call it a matching transformer between a low impedance and your higher impedance. So it's something to be knowledgeable of, and 75 ohm coax is very useful. As I mentioned earlier, with getting this stuff off of Amazon, the quality varies by manufacturer. Absolutely. If you want quality material, stick with a well-known, reputable manufacturer. And there's a lot of them out there. Times Microwave, LMR 400. I'll plug those guys. That stuff's expensive. Well, I shouldn't say it's more expensive than your typical stuff you might get from DX Engineering and what have you. But it's a very high quality double shielded coax, so it's good. It's good stuff. Time and use, yes. Over time, exposure to the elements, in particular, getting moisture into coax will really affect the quality of the coax. It'll over time, it'll really destroy it. That's why you want to make sure you have watertight connections. If you use, I know we're going to talk about connectors, but if you use UHF connectors, make sure you seal them. Use some type of a seal so they're watertight and water can't get into the connector and into the coax. It will wick into the coax and it'll eventually corrode and cause all kinds of problems. Yeah, mishandling is a big problem. Putting too sharp a bend in a piece of coax will damage the coax. What it can short it out. It can cause the center conductor to actually be displaced in the dielectric and go rub up against the shield. So tight bends are something you want to avoid. That's it. So different types of coax. Here's the list of all the different types that are usable. We use all of these. RG174 is great for making entry that's not noticeable. It's really tiny stuff. It's like a quarter of an inch, smaller than a quarter of an inch in diameter, but it is lossy as you go up in frequency. So you don't really want to use this on 2 meters, for instance. It's going to have some loss, but it's great for receiving antennas and things like that. It works great. RG58, really common stuff. It's lightweight. It's inexpensive. RG58A/U, 50 ohm. It's not as much loss as the 174, but it's a little bit bigger. But again, it's nice and compact, and it can 100 watts easily with RG58. Great for using with QRP rigs. Same thing with RG174. A short run of RG174 with a portable QRP rig is great because it's super lightweight. 59 is your 75 ohm. Like CATV type coax. So it's going to have a little bit more loss, but RG59 is just about the same size as RG58, and both of those require an adapter when you use a UHF connector on it, because the UHF connectors are designed for a 1/2 inch coax, like the RG213 or RG214 or LMR 400 or 9913. These are all high, the LMR coax and the other RGs are very high quality coax, low loss, well shielded. Okay, connectors. Okay, PL259. These are the ones that you're most common with. They're referred to as a UHF connector. These are the ones that are most commonly on all of your HF radios. Are PL, or actually, it's the radio has an SO239, which is the UHF socket. PL259 is the connector that goes into that SO239 connector.
This is the slide that we had from the VHF, UHF, so we can only have to worry about the first two on this one. We can ignore everything on the bottom.
Actually, yes and no. I can talk about the others.
Okay.
Use BNCs a lot for interconnections, for test and what have you at HF. I wouldn't use SMAs at HF, but end connectors, most definitely. A lot of the equipment that I have here, a lot of, Anthony was alluding to that. Yeah, I'm a bit of a vintage radio collector, just a bit. One of the manufacturers that I collect a lot of equipment from is Collins Radio Company, and a lot of their gear had type N connectors on the HF gear. So yeah, all the stuff that I've got sitting here on the desk in front of me, and the stuff sitting on the desk behind me, a lot of this gear has type N connectors. So they're great. Actually, I like using type N connectors because they are waterproof. I don't have to worry about putting sealant around the UHF connectors on antennas and things like that. So it's really a nice. It's harder to install, but if you're using the crimp connectors, it's easy. It's just as easy as putting on a UHF connector when you're crimping them. F connectors get used for receiving antennas, believe it or not. I've got some receiving antennas that use that's a standard, your standard cable TV connector. So they are useful for HF. Don't shortchange them. They're inexpensive and readily available. They're great for certain applications. So there you go. You can go to the next one there. Okay. Yeah, I mentioned this crimp connectors. Yeah, so type of connector, different types of installation, the way you install them. Some connectors are soldered, some are crimped. crimping is easy. I mean, it makes it really simple. We've got tools that actually strip the jacket and cut the braid and cut everything to length. Little tools that you can get that do all of that stuff for you, or you can just use an X-Acto knife and a pair of wire cutters and do it yourself. But I like the tools that do that. And like you say here, the PL259 is installed directly on RG8 or LMR400, RG213, 9913. All of those are direct installation. And you've got a guide here for installing them. To put the PL259 on RG8X, all it takes is a little adapter that you add to it. So, and I like that last thing. There's no shame in buying coax with pre-installed connectors, but make sure they're high quality. Absolutely. Uh-huh. Yeah. Getting in the shack. This is always fun. Yeah, I've done everything to get things in from laundry vents, the clothes dryer vents. I've used those. PVC pipe through the wall. You can buy commercial bulkhead panels. MFJ has a really nice one and I think that's what you've got illustrated down there is the MFJ bulkhead panel. It just goes into you can go into a window. If the window has a sliding opening, you just stick that in there and buffer it with a piece of wood or something, and you've got a nice entry panel that's bug proof.
On the temporary one that's listed down here, I always used to use a bunch of towels. I'd bring, because we were on vacation, so I'd use towels, because a lot of times we're using an Airbnb for our vacation, so we can't really install anything. But I found something better. I've been using pool noodles lately. Pool noodles are very inexpensive, and they give you a nice fit so you don't get insects back in or water or things. So I've been using pool noodles, but I wouldn't suggest using them long term because it's hard to secure your house with pool noodles.
With pool noodles, yes.
They also work on sliding glass doors, so you can put a vertical pool noodle so you don't smash your coax on the sliding glass door.
So my setup is kind of like that last picture there with the I've actually got a closet outside that has a backboard in it with a bunch of light. Those are lightning suppressors, static suppressors that are on there, like polyphasers and the like. And that's how I do my entry. So I have all my cabling coming into one location. Well, most of it comes into one location. The loop comes in the shortest path. It comes through the wall right behind me up there. Okay, antenna tuners. We talk about these things as tuners. They don't really tune the antenna. They're really an impedance matching network. That's what it really boils down to. The antenna may present something that's not 50 ohms to your 50 ohm radio. So we use an antenna tuner or a matching network to adjust the impedance of the antenna to the impedance of the radio. This is important. Just because an antenna is resonant doesn't mean it's going to be 50 ohms either. It could be all over the place. So you'll find that antenna tuners or couplers or matching networks are a very handy thing to have. Allows you to operate with a lot of different antennas and use many different types of antennas with your radio that may have a limited tuning range. So antenna tuners, there you go. I like to, one of the things that I will comment on this is that my take on we talk about putting together a station. Your station is a system. No one piece of it stands alone. Everything interacts with everything else. So your antenna interacts with your transmitter. The changes in your antenna will affect how the transmitter matches the antenna. So the tuner and all the feed line are all part of that system, from the transmitter all the way out to the antenna. So you have to be aware that those things are all interacting all the time. So this is something to be aware of. Yeah, the types of external antenna tuners, that's these guys up here, pointing up there on top of I can't get my finger in the right spot. It's too hard. Oh, God, there it is. Those are tuners. Well, antenna matching networks up there. These are matching networks here in this rack. And they're all for matching different antennas. So these are all locally, some of them are manual. This guy up here on top is automatic. I just put RF into it and automatically tunes the antenna. There's a lot of those out there, and they are really neat. You can have a remote mounted antenna tuner that goes at the antenna to make sure that it presents a 50 ohm load to your coax going back to your transmitter. That tends to be a little bit more pricey or spendy, but remotes are great. Most radios these days have a built-in automatic tuner, but the typical tuner will only cover about 3-to-1 SWR, which is okay. But you really might want to have something a little bit wider if you have a wider range of SWRs on your antennas. So on the subject of SWR, we're going to talk about that in a little bit. But yeah, this is all good stuff. How antenna tuners work, antenna tuners, impedance matching, and SWR. This is all good stuff to read up on. There's some great books out there from the ARRL on tuners. But let's talk about SWR, good old standing wave ratio. And there's a lot of misconceptions about this. What is SWR? In this case, we're going to talk about the ratio of the power out of your transmitter to the power being returned back as a reflection from the antenna or the load. That is SWR. If we look at the voltage ratio, that's called voltage SWR, standing wave ratio, or you'll hear the term VISWAR, power and voltage. Everybody thinks that it's important that you got a 1-to-1 match, that the SWR's got to be 1.0 to 1. Well, if I've got it over 2-to-1 or 3-to-1, I'm going to blow up my transmitter. I'm going to lose all my signal. Well, this is really a misconception. It's nonsense. If you look at the chart, this chart gives you the ratios of SWR between 1-to-1 all the way up to 10-to-1, and gives you a percentage of loss of the power. Okay. So if I've got a 3-to-1 SWR, I'm losing power. I am going to lose some of my signal, but I'm only going to lose 25%. 25%. That's not a lot. It's basically, if I put in 100 watts, I'm going to lose 25 watts. I'm going to radiate 75 watts. The guy at the other end won't even know the difference. He wouldn't be able to measure that. It's not even a single S unit. It's a fraction of an S unit. So this whole idea of having a perfect SWR is kind of a misnomer, and it's not necessary. It helps. I mean, if you use a tuner and you get your match down to 1.1, 1.2 to 1, this is great. You know, you're going to be a lot more efficient. You're going to get more power out of your antenna. But you know, the proof's in the pudding. And if you talk to the guy at the other end, reduce your power by 75% and see how much things change. They don't change a whole lot. So it's interesting. But I like to see SWR low. I have one particular piece of equipment sitting back here behind me, an amplifier that's a amplifier that does not like to see a high SWR, and it considers 1.2 to 1 a high SWR, and it will fault. So I have to be careful of that. But this is something to be aware of, and take it to heart that having a high SWR is not necessarily such a terrible thing that you're not going to get any signal out. Even at a 10-to-1 SWR, you're only losing 2/3 of the signal. So you still got a substantial signal out there. So be aware of those compromises, and happy hamming.
Well, we made it, Dennis. We're at the end of another session.
Oh boy.
We'll go ahead and take questions here. Again, if you want access to the slideshow, this will give you all 3 weeks slideshow in one place, and I promise that I will update the Anderson Power pulled this picture wrong, and I'll fix the one place where there's 2 commas in a row, but that'll happen after tonight. So we'll go ahead and take questions. Again, we covered last week the HF bands and HF operating, but we didn't get a chance for a lot of questions. So we'll be happy to take questions on last week or this week, both.
I see a question in chat right